Now, corresponding to question, first of all read the question. According to question, a block is released from rest. This block is released from rest means initial velocity is 0. Initial velocity u is 0. Clear? From rest at a smooth track at given position. A smooth track means whatever friction mu is 0, that is a smooth track. Clear? It means non-conservative force is 0. Non-conservative force is not working here because that is 0. Frictional force is a non-conservative force. Here 0. Okay. Then find the maximum compression of the spring. So our motto to determine maximum compression of the spring. Okay. So how can we determine? First of all, you focus on work energy theorem. Okay. If you apply work energy theorem, or better to apply here conservation of mechanical energy. What about conservation of mechanical energy? Delta K plus delta U, this will be equal to 0, means change in kinetic energy plus change in potential energy, this will be equal to 0 if all work done due to external force is 0. Okay, or you can say the external force by work done is 0. External force 0 or not is not necessary condition. Its necessary condition is that all work done by external force is 0. Clear or not? Since you look here, if in doubt, now look at any point in between this surface is like that one. If you consider this block is moving corresponding to here, okay, mg downward, normal force here, friction force is not available, so we have not represent here. Normal force in all point are changed. Why? Because of surface like that one, it is curved surface, that is curved surface. So external force is available here. Clear or not? And it is changing all point. It is changing all point. Clear or not? Means n is basically n is the variable force and external variable force. It is changing point to point. Okay. So work done by n, what about work done by external force n? I know that if you see very carefully, for very small distance, infinitely small, if you take very infinitely small, that is, you can say that okay, if you consider very infinitesimally distance, your displacement we take, that is dx. In this duration, what about n? N is perpendicular to dx. Clear or not? If you consider at any point very small, infinitely displacement, it is very small. In this duration, that curve is represented a straight line like that one, and n is perpendicular to that one. So work done in this duration, what about work done? That is 0 because of f n into dx cos 90. So you can say that for infinitely displacement, work done due to normal force is 0. So if you consider from here to here, that is curve surface. So additional for this one, or you can say the summation of dw, that is 0. dw, summation of dw by external force means normal force, that is 0. Clear or not? So you can say that due to external force, work done by external force, sum of work done by external force is 0 or not? Clear or not? 0. From here to here, clear? So you can remove. So work done due to external force is 0. in this duration, okay, here to here. Clear? Now, and second one, if this block is going on here for final position, then what about the spring? Spring is compressed. What about spring? Spring is compressed like that one, and block after compression it is covering whatever this S max distance for maximum compression, okay. And what about block velocity at that time? Final velocity of block is 0, okay. Clear or not? Clear or not? Now, if you see here very carefully, again, if due to some conservation of mechanical energy, or you can say that after some time this gains some velocity at that point and push this spring. This block push the spring. Spring exert force in restoring force corresponding to here, okay, and that block, this surface, if spring exert force here, then this surface also apply force. Which direction? In here, okay. Clear or not? Or you can say that this spring force apply here, and then, okay, corresponding to, if any doubt, then see here in micro level, this block is going on, apply force here, spring apply force here. Clear or not? Okay. If block, suppose the velocity v, then and up force apply, force direction like that one, spring also apply here force. Clear or not? Very simple. Then what about that wall? This wall also feel force. Why? Because of, if this one here compress to spring force apply here. Now look here, this one apply here force, and this wall also apply force here. Clear? Clear or not? It means again external force. Here there is external force or not? Wall is an external force. But due to this external force, due to wall, no work done. Wall is not moving here to here or here to here. So work done by this external force is also 0. Clear or not? So work done by this external force is also 0. Clear? So sum of all external force, sum of work done by all external force is 0 or not here. And what about non-conservative internal force? 0, because frictional force is not available. So only frictional force is here, that is internal conservative, that is 0. Sorry, not non-conservative. Internal non-conservative work done is 0, because the frictional force is not available here. So work done due to internal non-conservative is 0. Clear or not? So according to our work energy theorem, external work done plus internal work done due to conservative force, work done by conservative, work done by internal non-conservative, force, this delta K. Clear or not? Non-conservative force, work done due to non-conservative force is 0, because frictional force is not available. So you can say the internal conservative due to work done due to non-conservative force, that is 0. Now this is also 0. Work done due to external force is 0, okay, corresponding to N, and this wall due to corresponding to that one and corresponding to that wall. Here 2 external force, that is 0 because this one is not moving. Force is available but force is not done, work done. That's why work done due to wall is 0. Work done due to normal force, this is also normal force is also external force due to this normal force is 0 because of for very finitely displacement dx means displacement dr, infinitely displacement dr and normal force is perpendicular. So, work done for very finitely displacement due to normal force it is 0. So, sum of here to here total work done for normal force is 0 because sum of this one, if adding then we got 0. Clear or not? Clear or not? So, work done due to conservative force here gravitational force and this is minus delta k, this will be equal to minus delta u. So, this one is 0 and this one is 0. So, this will be equal to delta u, this will be minus delta u, this will be equal to minus plus delta k. So, if this one is going on here, then we got that one. This is called conservation of mechanical energy. Clear or not? Why this is valid or not? So, clear why this is valid or not? So, we have focus on question, okay. So, we have start here question. Why it is clear or not? Why this is statement written here? So, you can say that Ki plus Ui, okay. This is delta K means final minus and this is also written as this will be equal to 0. That's why written here as initial potential energy, okay or not? It is right or wrong? Right. Now apply here. Now what about potential energy? We have first of all we have considered potential energy at that point is 0, okay, that is a reference. So, what about potential energy at that point? That is mgh. So, initial potential energy is mg capital H plus what about spring potential energy? Because of here potential energy due to mgh plus spring also available. So, you can start now. So, potential energy due to spring and potential energy due to height, gravity, okay. Here two conservative force, gravitational force and spring, okay. Spring also conservative force. So, potential energy of due to gravity, that is mgh. Now, at original length, what about potential energy of the spring is 0. At original length, that is spring, potential energy is 0. So, that is 0 plus what about kinetic energy? Kinetic energy of that block is 0. Why? Because of initial velocity of the block is 0. That is why. This is equal to final kinetic energy after compression of the spring, maximum compression of the spring. What about velocity of this block is 0, again 0. So, 0 plus what about potential energy? Potential energy of the due to gravity, potential energy due to gravity of the block is 0 because of the in that point, okay. This is the corresponding to that one, that's why. And last one, what about potential energy due to spring? Potential energy due to spring. Now, spring compress of this block, maximum compression is x max. So, you write now here half k into s max to the whole square. Clear or not? So, potential energy of spring is like that one. So, s max is very clear. How much? 2mg into h divided by k. Okay, this is the final answer. This is the final answer. Make it.